Okay, so if we have that P is equal to M times V. So you have final over here and initial. So 2 times 4 was 8 kilogram meters per second. Over here we had 20. Everybody okay with how we got those numbers? So instead of, like before, they were already given, we just had to do a quick multiplication. So to get our momentum from 8 to 20, we have to increase our momentum by how much? 12. So delta P would work here.
I thought it was the V's.
I
thought you just used the V's. I thought it would be 6 because I thought you would just minus 4, 10 minus 4. It's 6. That's what I've been doing the whole time.
Well, because in the other ones they gave us P instead of V. They already gave us the momentum. So, a change in velocity is going to wind up causing there to be your change in momentum, but because of this, right? So multiply these two together. This would be the unit was like the kg. Good God. Meters per second, and the same thing for 20. So we increased it from 8 to 20, so that means we would have to do this guy. Or, now if this answer was like the number 2 for seconds, it could be that one as well, because force times the time is a change in momentum. So 6 times 2 would give me 12, which would be the same. All right, how do I... Okay, so this one should be... Yurt. Okay, so what's 12 times 8?
94. 6.
Okay, so we got 96 initial momentum. 8 times 8?
64.
It's an awful 6, sorry. So what is my change in momentum? What's 96 minus 64? 32. So we need to look for something that's going to give me 32, but wait, we decreased it, so it's got to be a negative. Our momentum changed by 32, like a negative 32. So which one would that be? You're not wrong. Good stuff. Okay, now if we really wanted to, I honestly was like losing my mind yesterday. I also, like, my brain was hurting, so. Oh, let me just clear steam. This thing, I was bugging out. I couldn't really figure out what in the hell they were asking me for. Oh, now I think I got it. Okay. So what is our initial velocity? Or I'm sorry, our initial thingy here. What is our initial momentum? What's 14 times 8? Somebody? Yeah, like 6 of you got your phones out, so I would like it, just really quickly get your fucking calculator out. 112? Okay, so we are originally at 112 kilogram meters per second, and 8 times 24.
192.
192? All right, so 192. Okay, so how much did we change by?
80 something. 80.
So delta P would be 80 even?
Yeah.
All right, so now we need to figure out, there's like 2 collisions that basically you're going to, I guess, have to add up to that. So what's 16 times 2?
32.
That's 32. What's 32 and 48 equal?
32, 80.
Okay. So let's try that. So basically this is saying like you collide into one thing and then another. So like imagine you push your little brother, sister, cousin, whatever, on a little like car, and they're 8 kilograms and they're moving at 14 meters per second. Then your other cousin, sister, brother, give them another push of 60 newtons over 2 seconds, and then the other person gives them another push, which changes it by another 48. So those two added together would give me that. I think that would make sense-ish. So let's give this a shot. We would have you and you. Great. I could do it today. Yesterday after school, I was like going over a bunch of stuff, and like I was just staring at it, and I was like, huh? Sometimes you need to step back. That's a challenge. That was a little bit of a challenge. Yeah, it was. No? Okay. Oh, shit. You don't want that. All right. So then let's do this one. Oh, can I? All right. So what is 2 times 4? All right. So this is 8. 16 times 2. Delta P is what? What is our total change in momentum? 32 minus 8. Okay, so we need an impulse / change in momentum that are going to give us this dude here. So we need to go up by 24. I don't really see what two guys add to 24. Because 48 times 0.5 is 24, right? But we have to select two things. So that wouldn't work. What about if we do a positive 32 and a negative 8? A positive 32 and a negative 8 would give us a net of a positive 24. All right, so let's try that. No, this one you're not. You're adding. So like an impulse would be like like over here, like a force over a certain period of time. So if I did that, that would be the same as saying my impulse was a positive 8 Newton seconds. And if I increased my like change in speed by a certain amount, that's going to cause there to be a momentum change of this. So basically that would be like you're getting pushed along, someone gives you a change, adds to your momentum, all right, adds 32 of it, but then you like run over a little bit of a grass patch, which slows you down. It provides an impulse of negative 8. So positive 32 and a negative 8 would net a 24, I believe. Let's see. Hot dog! Hell yeah. Pumped. How do I? Okay. Dope sauce. Hell yeah. Big time. All right. Let's reload this. So, guys, in order to change an object's speed, what do you need to do? All right, to slow it down or to increase. How are you going to do that? How can you change the speed of something? Push it or pull, and a push or pull is what? Begins with an F. Applying a force. So a net force that's greater than 0 is going to cause there to be a change in motion or an acceleration. So an acceleration is a change in velocity over a certain period of time. So guys that play baseball, right? Imagine someone's taking a ball and they throw it at you. Are you always going to have like your hand like stuck straight out and very stiff? Why not? You're going to stop it, but what is that going to do? It's going to hurt. It's going to hurt a little bit. Instead of when you do that, you kind of give with it. Like as you're catching it, you move it like back with you a little bit. A lot of times they'll do that into like a throwing motion. So why is that? You're changing the momentum from whatever it was to 0. But one takes longer. The one that takes longer hurts less. So you can stop, baseball with your bare hand if you hold it stiff, straight out, all right, lock your wrist. You could stop it. It's going to probably sting a little bit versus if you were able to kind of give with it. You're extending the time of impact. This is what the impulse and momentum change like theorem is. All right. So here's this connection. Obviously, we need a force to cause there to be some sort of change. Newton's second law. A force exerted on a mass is going to cause there to be an acceleration. All right. Well, an acceleration is a change in velocity over time. So delta V divided by T. So literally, the only thing that was happening here is they replaced A with this. All right, because another definition for acceleration is a change in velocity over time. Okay, well, I don't like that T's on the bottom being like divided by over here, so what can I do? Multiply both sides by it, and now we have this. So an impulse is basically, all right, applying a force on an object, all right, for a certain period of time. Whatever that product is, multiplied together, is going to cause there to be a direct change in momentum. So if I apply a force of 2 newtons for 1 second, my impulse would be 2. My change in momentum would be 2. Now, since mass can't change, we're really only changing velocities. All right, other examples. If you're going to jump, how do you land? If you're jumping from a height of, let's just say, or landing from a height of 2 feet, how do you land? On your feet. Do you bend your knees at all? No.
Maybe not from 2 feet.
You're not going to try it, but I've done it from about 6 to 8 inches, just for like the example. Try to land flat foot, no bend in the heels, knees, or hips. It hurts a lot. It's not fun. And we're going to go into a reason why in a second. But, well, what you're doing is you're changing your momentum, right? You have your mass. By the time you get to the ground, right, you're same distance, gravity's accelerating the same, so you're going to be hitting the same speed. You're going to be hitting the ground at the same speed. So 1 stops you quickly, which means it requires a larger force. Versus when you bend your ankles, knees, hips, you're extending the time, which reduces the overall force on your body, and it doesn't really hurt, right? That concept applies to a bunch of different things. It can be in sports. It can be in a car. All right, they have safety features for this. Seatbelts, okay? They are supposed to, when you slam on the brakes, they're supposed to lock, not immediately, but give an inch or 2 inches and then lock. Why? Because of that, it's extending the time of impact, which decreases the force. You have the airbag that comes out. All right, your face hits that, and the airbag caves in, extending the time, decreasing the force. The front of the car has a crumple zone. So instead of like older cars that are made of steel, like they ran into a wall, like it wouldn't really, depending on how fast, wouldn't really destroy the whole car. Whereas newer cars, more modern cars, yeah, like the whole thing would be crumpled and we would be like, all right, it's totaled. Why? Because, again, same idea. Increase the time, it winds up decreasing the force because you've got to change the same amount of momentum. So like in this one, you have a ball that's coming in at 10 meters per second, it bounces off, coming backwards at 5. Over here you have 30 going towards it, 28 coming off. Which one has a greater change in velocity? A or B? Well, what is the equation for change in velocity? Delta V is VF minus VI. So VF minus 10. But now the direction mean it comes into play. So if it's coming this way, it's a negative. The 28 coming this way, it's a negative. So we have negative 5 minus 10. What does that give me? A change of 15. And what about the other one? We would have a negative 28 minus 30, which would be a negative 58. So then who undergoes the greater velocity change? Case B. Okay, greater change in velocity over the same period of time, we're assuming, means greater acceleration. So B would be that as well. Greatest momentum change has to deal with the greater change in velocity. So again, B, and the impulse is equal to the momentum change. All right, so they have all of that stuff here for us, so an explanation. So this website does a good job of like giving us some breakdowns here. Looking at this velocity time graph, this is a speed time graph. So this dude up here is at 5. And he goes down to what speed? A negative 3. So how much did he change his speed or velocity by? 8, right? Over here, we're at a positive 3. We go down to a negative 1. So we change it by 4. So who goes greater velocity change? A, which means greater acceleration, right? Because they both do it from 3 to 5 seconds. 3 to 5 seconds, so over the same amount of time. So yeah, A would have the greater acceleration, momentum change, and impulse. Okay, there's a couple other things in there that you can do. Aha. Now I want to do this. Shoot. How do we deal with this right here? Okay, so momentum change. That's delta P, which is just equal to the object's mass times change in velocity, which is delta V. Impulse, all right, we can call it I, but we usually say it's F times T, right? This is F times T is going to give us our impulse. And the other main equation is the impulse is equal to the change in momentum. All right, so with all that, I have a mass of 10 and a change of velocity of negative 4. What is my momentum change? So what's 10 times negative 4? 10 times negative 4, 10 times negative 4. Negative 40. And here you go. You got negative 40 kilogram meters per second. Boom. In the wording or in the information that was above, it says that impulse is equal to the change in momentum. So that means our impulse is also going to be negative 40, but the only thing that changed was the unit. Why? Because here you're multiplying kg times meters per second, kg meters per second. Over here, an impulse, okay, is a force times the time, so that's why our impulse is in Newton seconds. They multiplied the units. All right, bet. So over here, if I had, if I know my impulse was that negative 40 Newton seconds, and that equals the force times the time, but I don't know what the force is, but I know that time is 0.01. So how do I get F? Divide both sides by 0.01, and what does that equal? 4,000, negative 4,000 newtons. I don't want to actually do all of that. I want to erase just this guy. Okay, so the next one. All right, well, the next one I'm not given mass. Oh, I am given mass, but I'm not given velocity change. I'm given impulse. So again, impulse and change of momentum equal each other. So this should be negative 40 kilogram meters per second. Let's check. All right, so if I know that this is 40 or negative 40 and I know the mass is 10, negative 40 divided by 10 would give me a negative 4. Oh, shit. So, in both 1 and 2, I'm changing my velocity by -4 meters. So I'm slowing down by 4 meters per second. The mass is the exact same. So I'm going to change my momentum the same in each problem, which means I have the same impulse, but in one of them, I'm dividing it out by 0.01 seconds, and this one I'm doing it by 0.1. This one takes shorter amount of time, which means, a longer period of time, which means the force has got to be less. So -40 divided by the 0.1 is going to give us -400 newtons. Okay, and you can kind of go around here and play around with that. And then the last thing is this dude here. Simplest relationships that we got. You have force and time, impulse, change of momentum, final momentum. They're telling us right off rip that the initial thing is at rest. If something is at rest, how much momentum does it have? 0, because mass times velocity. All right, so if it's not moving, it's at rest, 0. So force times time. What is 12 times 4? Smiles. What's 12 times 4?
48.
Good. You are just a tremendous ventriloquist. You like threw out your voice all the way to the back. It sounds exactly like you too. So if impulse is 48, what is the change of momentum? The exact same. Those two are equal. All right. The reason why I'm going through this, guys, is to harp under. If you need to understand this in order to do like more complicated problems. So 48. Well, if I was originally at rest, that means my final momentum is going to be, it's got to be 48 because I change it by 48. So 0, change it by 48, becomes 48. Can I check the answers? I can. Yeah, I know I still need some. All right, green says I'm all right, bet. You can kind of flip through these. Okay, well, crap, I don't know what this dude is. What do I do? Well, change of momentum is the same as the impulse, so that one would be 16. That means, again, I'm going from 0. I have a momentum change of 16. How do I figure out the force? Well, you could say that impulse is your force times time, right? So if I have 16 divided by 0.05, what in the heck is that? Yeah. What is, all right, let's do 16 divided by 0.05. Holy damn, 320. Okay, they're both, all of them in the green. Okay, sick. Not terrible. Up to main menu. Yep, return. So let's make it a little bit harder. So in this case, what can I do? If I have force and time, what can I get? I can get impulse. What's 3 times 6? 18. If my impulse is 18, what's my change in momentum? 18. Okay, well, wait a tick. I can't say this one's 18 because why? I have an initial momentum this time. So this one was 32. So what's 32 plus 18? Yup. Let's just check. Oh, Molly, you want to do the next one on your own? Got it. Perfect. Love the energy. If the change in momentum is 28, we're going to look at letter C. All right, don't freak out. If the change in momentum is 28, impulse has to be the same. So if we know one of these two, we automatically know the other. So we're just going to type in 28. That I know is guaranteed correct. So an impulse is a force times the time. And so I is 28 and T is 0.5. So to get F by itself, I would divide both sides by T. Does that make sense? So if I put the numbers underneath, right? So like let's say I put the impulse was 28 equals F times 0.5. How do I get F by itself? Divide both sides by 0.5, yeah? So then you would do 28 divided by 0.5, or 28 times 2. And what would that give you? Okay, good. So then this here would be 56. Now, if my initial momentum was 72 and my change was 28, 72 plus 28 is going to give me, so I would have a final momentum of 100. Now let's check that. They all green. Hell yeah. Okay, so guys, I will post a link for this so you guys can practice. Let's just try the last hardest one. Shit. Okay, so, all right. So you have mass. The mass isn't going to change, but your velocities will, which means your momentums will. So what is my initial velocity? 8 times 6 is how much? Okay, 48. Good. Now, if I have an impulse of 32, what does my change in momentum have to be? 32. Bet. Okay, so now, what would my final momentum be if my initial is 48 and the final is 32? Well, oops, I made a mistake. Let me clear that. So I thought this was delta p for a second. So if we're initially 38 and an impulse is 32, that means our delta p, or change in momentum, is 32. So 32 plus 48 would mean, is that what, 80? Okay, so if I know that my final momentum is 80, and now I can figure out my final velocity by just using this equation. The mass didn't change, so this was 8. This is 80, right? Our final. So divide both sides by 8, and we should get how much? Excuse me, 10. All right, so let's do that. All right, let's check it. Let's check it. All green. Bah, 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 bah. Yeah. All right. Good stuff today. Very good stuff.